change software development from a craft, where skilled artisans can create one-off works, to an engineering discipline, which implies repeatability, rigor, and effective analysis. While software engineering still lags behind other types of engineering disciplines by many orders of magnitude, to be fair, software is a very young discipline compared to most other types of engineering, architects have made huge improvements, which we'll discuss. In particular, modern agile engineering practices have allowed great strides in the types of systems that architects design. We also address the critically important issue of trade-off analysis. As a software developer, it's easy to become enamored with a particular technology or approach. But architects must always soberly assess the good, bad, and ugly of every choice, and virtually nothing in the real world offers convenient binary choices. Everything is a trade-off. Given this pragmatic perspective, we strive to eliminate value judgments about technology, and instead focus on analyzing trade-offs to equip our listeners with an analytic eye toward technology choices. This book won't make someone a software architecture overnight. It's a nuanced field with many facets. We want to provide existing and burgeoning architects a good, modern overview of software architecture and its many aspects, from structure to soft skills. While this book covers well-known patterns, we take a new approach, leaning on lessons learned, tools, engineering practices, and other input. We take many existing axioms in software architecture and rethink them in light of the current ecosystem and design architectures, taking the modern landscape into account. Chapter 1. Introduction. The job software architect appears near the top of numerous lists of best jobs across the world. Yet when readers look at the other jobs on those lists, like nurse practitioner or finance manager, there's a clear career path for them. Why is there no path for software architects? First, the industry doesn't have a good definition of software architecture itself. When we teach foundational classes, students often ask for a concise definition of what a software architect does, and we have adamantly refused to give one. And we're not the only ones. In his famous white paper, Who Needs an Architect?, Martin Fowler famously refused to try to define it, instead falling back on Ralph Johnson's famous quote, "Architecture is about the important stuff, whatever that is." When pressed, we created a mind map with myriad interconnected branches, from evolutionary architecture to patterns and anti-patterns, to continuous delivery to technical and soft skills, among dozens of others, which is woefully incomplete, but indicative of the scope of software architecture. We will, in fact, offer our definition of software architecture shortly. Second, the role of software architect embodies a massive amount and scope of responsibility that continues to expand. A decade ago, software architects dealt only with the purely technical aspects of architecture, like modularity, components, and patterns. Since then, because of new architectural styles that leverage a wider swath of capabilities, like microservices, the role of software architect has expanded. We cover the many intersections of architecture and the remainder of the organization a little further on. Third, software architecture is a constantly moving target because of the rapidly evolving software development ecosystem. Any definition cast today will be hopelessly outdated in a few years. The Wikipedia definition of software architecture provides a reasonable overview, but many statements are outdated, such as, software architecture is about making fundamental structural choices which are costly to change once implemented. Yet, architects designed modern architectural styles like microservices with the idea of incremental built in.